Hello.
Hello! We're back.
What's up?
What's up? It's been a while, right? We missed the month of July because vacations.
Because life and
Life.
summertime and everyone's trying to, live life a little
I
bit
know, right?
as they
I
should,
know.
as you all should.
Yes. But now we're back for
So that,
the latest What's New in OTel.
hello, I'm Reese.
And I'm Adriana. And I'm
And
calling from Toronto, Canada.
oh, yes, I am coming in from Portland, Oregon. If you've followed along with our programs, you know we love seeing where everyone's tuning in from. So if you want to just drop in the chat, whether you're listening in on YouTube or LinkedIn, it's always fun to see where people are tuning in from.
Totally. And especially if you're tuning in from non-North American time zones. Thank you for tuning in because I know it's late for you. So
Yes, or
definitely
depending on where you
appreciate
are,
it.
it could be really early.
Oh yeah, that's true. That's true. So
Yeah.
yeah. So
Um, well, also, if you have comments about our intro music, I would love to hear them. It was just something that was available, I think, in like Canada.
I like the intro music. It
I
was
do
lots
too.
of
I'm not really
fun.
in the back to it, but
Wanted a bop.
it's yeah. So hello. We have an exciting episode for you today. We'll start with some OTel news, news from around the project, and then we have a very special guest that we'll introduce in a little bit. But yeah, hopefully you all are ready to gather around. So first up, and this is pretty cool. So the OpenTelemetry demo SIG released Astronomy Shop version 3.0 last month. If you haven't checked it out before, the demo app is a fantastic way to learn about OTel instrumentation and see how things work under the hood. It's set up so that you can easily, send the data, get it up and running, and send the data to any backend of your choice. It's an e-commerce app that's structured as a microservices, and the microservices are written in just about every major language. And since 2022, it's been a living reference for demonstrating what OTel can do. So version 3.0 now covers, are you ready? It's a lot. Agentic AI systems and how to instrument them, continuous profiling alongside traces, metrics, and logs, a mixed instrumentation setup that demonstrates zero code instrumentation as well as manual instrumentation,
Ooh.
open feature flag evaluation with telemetry, database query correlation via SQL commenter, different standards to replicate real world production scenarios. And that's actually not even all of it. But yeah, I'm a huge fan of leaning on the demo app for workshops, talks, using it to experiment with processors and configs. So huge kudos to the demo SIG on this major release. If you haven't tried it out, it's really easy to clone to your local machine and have it up and running. They have a load generator that generates telemetry for you. So yeah.
And also you can hook it up to your favorite observability backend as well. If you want to go beyond just the tools it ships with. But yeah, I agree with you. I'm a huge fan of the OTel demo. I have been using it through the years, and it's wild to see how much it has grown as well. Went from like this little tiny thing to like whoosh.
Yeah. Also, if you would like to contribute to the project, the demo app, the demo SIG is a great place to look into.
Very true.
Right there.
Absolutely. All right. And in other OTel news, we have the OpenTelemetry Transformation Language, or OTTL, which has just added support for Lambda-powered functions, which gives pipeline administrators finer control over sanitizing sensitive data, always a big one, normalizing schema mismatches, and enforcing attribute policies. So that's super cool. OTTL is one of those unsung heroes of OpenTelemetry, I would say. And you actually did a blog post like semi-recently on OTTL. There's like so much cool stuff you can do with it. It's wild.
There is. And actually, I will be doing a talk on Tuesday at KCDSF, which I'll talk a little bit more about later with Julia First Morgado about OTTL. So it is pretty neat.
Right on.
Also use the OTTL playground, which you can find at ottl.run, to test it out yourself. It comes
That's
with
cool.
it's actually really, really neat. It comes with like default like payloads and configs you can try, but you can like modify them and like add in your own payloads and see the transformation and see if your configs are working or not.
Yeah.
But yeah. Also,
that's awesome.
if you have always wondered about the concept of entities, we have got a great guide that was just published on the blog by Matteo Norbuson. I so hope I'm pronouncing your name correctly. But it's a great guide. It goes deep on OTel entity events and details how to track topology shifts and dynamic infrastructure lifecycle. So like host services, interfaces alongside your telemetry.
Awesome. Also, I just posted a QR code for the OTTL playground. So for anyone who wants to scan it, it's right there. Now, speaking of great guides, Siho Thomas has contributed an awesome new blog post about cardinality. And I think this is an issue that is probably near and dear to many organizations, so definitely worth a read. And it outlines how the SDK level cardinality cap prevents unbounded memory growth when metrics encounter high cardinality attribute bursts. So definitely check it out. And we'll also, as part of today, actually specifically, we'll be chatting directly with one of the maintainers who brought this to life. But the Packaging SIG recently introduced native Linux OS packages, which brings you zero-touch system dependency installation and auto-injection to standalone Linux hosts, which is super exciting. And on that note, we are going to welcome our guest, Michele Mancioppi. Hopefully, I did not butcher your name. Welcome, Michele. Oh, and you are on mute.
I thought that the intro was absolutely fantastic.
Yes, score. Amazing. Well,
Hi.
welcome. And where are you calling from, Michele?
Germany.
Amazing.
Okay. Well, thank you for being on with us.
Yes, it is a late evening for you. So hopefully we won't keep you from enjoying what's left of summer. Okay.
We're ready in sweaters and trousers.
Oh my God, don't say that.
Oh, dang.
It's still 24 here in Toronto, so
I wish.
I'm holding on to it.
So Michele, would you like to introduce yourself real quick?
Yes. Hi, I'm Michele. I've been on the giving and receiving end of observability for roughly the past 2 decades. I have a thing, and my thing is to put telemetry collection into applications that do not have it out of the box. And this is what has led me first to contribute to OpenTelemetry, the OpenTelemetry injector, and now the system packages. Like if there is something that I really like is to be able to go point a finger and say, "OTel, monitor me that," and then it works.
Right
Very
on.
cool. Oh, and I've just put up a QR code for the Packaging SIG, which Michele had provided me with. So scan this QR code to check it out. Now, when just out of curiosity, when did you start contributing to OpenTelemetry?
I've been almost all along, but I was more on the kind of resource detection things. Another of my things is also semantic conventions and making sure that telemetry is very well annotated and consistent. So until like a few years ago, I was mostly on the product side of things at observability companies. And recently I went back to a more individual contributor position. So my amount of contributions has increased significantly. But I always tended to be like on the tactical side of fixing resource detectors. Like most of the AWS detectors, I've had my hand at one point or another because I needed them to be more consistent and useful than they were. And I could really scale up the contributions over the last couple of years.
Awesome.
That's awesome.
And so I don't know much about the packaging SIG. I would love to know more. So like, what was the primary motivation behind forming the packaging SIG? Like, what core gaps in the OTel distribution does it like kind of set out to solve?
So the I think OTel as a project is amazing. It has a lot of very powerful technology that does very complex things. If there is one criticism I can raise to it, is that in order to consume these technologies, one needs to have a lot of expertise, time, and being able to try things and read a lot of documentation that doesn't always agree, right? On the other hand, what I think is that the overwhelming majority of people out there, they do not necessarily want to know how to monitor an application. What they want is to have a thermometer for the fever of their systems. We all can measure our fever without knowing how heat is affecting the volume of mercury, right? And I think that the overwhelming majority of users out there should be able to set up monitoring without being monitoring experts. This means effectively two things. One, a delivery mechanism that's super easy to use, and this is where the packages come in. And the other aspect is to have very healthy defaults about how the telemetry is being collected, how it is being annotated, and how to consume it. Today, we talk about the first part.
All right.
Awesome. And so how did you personally get involved with the packaging SIG? Were you involved since the beginning? Were you like, what's the story?
I was chasing people down in Brussels last year, trying to convince enough people to start a SIG with me.
Right on.
The packaging SIG is the natural evolution of the injector SIG, which is something that we started last year around this time, with contributions from Destero and Splunk to effectively provide a complex piece of technology that is able to add to your, let's say, Java application without you doing anything, the OpenTelemetry Java agent. And the same for Python, for Node.js, recently for Ruby, thanks to the work of Matt Ware and others in the Ruby SIG. So we started with the injector, which is I would say, exquisite piece of technology using LD preload mechanisms and a lot of super cool stuff that I could nerd about for hours to effectively activate in your processes OpenTelemetry SDKs. And then the next natural step is, hey, I actually would like not even have to know that the injector exists. I actually want to go to my Linux machine and say, install me OpenTelemetry. And that should work. The OpenTelemetry project has other technologies that work in this way. The technical details are different. But for example, the OpenTelemetry operator, you can go and annotate on the pods which instrumentations you want to have, and you create a CRD, and then it works. Yeah, very similar mechanisms as for what the system packages do. And now that SIG is also working to get the injector that will automate a lot of the work, so you don't even need to annotate anymore. Awesome. OBI does something similar with eBPF, which is a completely different technology, similar result, and it is very complementary to the work of system packages. And if you want, you can go deeper in that. Another example is Lambda. You put a layer, a couple of configurations, and then your Lambda function is traced. The injector is this for pretty much any Linux-based application that runs Java, Python, .NET, Ruby, and TypeScript. And now the PHP SIG is also working on auto-instrumentation, so ideally we bring them as well in the fold. And the system packages is the delivery mechanism for your applications running on EC2, GC, Azure virtual machines, and any effectively Linux, where you actually go and deploy as systemd units, processes, you go start the JVM. If you use containers, there are other mechanisms. So sorry, I understand I ran out with that answer, but yeah.
Oh no, that was great. I'll probably need to like process it a little bit more, but um, can you kind of touch on, like, in plain English, like, how does zero touch instrumentation differ from traditional like zero code or manual SDK integration?
So it's a spectrum. Instrumentation is a spectrum. You go for manual instrumentation is when you go and program against the OpenTelemetry APIs the way you want your matrices to be collected, your spans to be created. You either do it in first-party code, your applications, or, for example, these instrumentations are built into the libraries you consume. That is native instrumentation. Automatic instrumentation is the instrumentation that it's a way to add the instrumentation to your applications without you needing to code. For example, in Java, you put the OpenTelemetry Java agent at startup in your Java virtual machine, and it will do a whole bunch of bytecode manipulation to do aspect-oriented programming, so put effectively callbacks before and after something happens and collect telemetry that way. Zero touch, often, not always, like OBI, for example, does something different, but most approaches that I was mentioning before, the injector, the system packages, the operator, Lambda, they take automatic instrumentation and automatically apply it to your applications. So this is kind of, it's a progression. Yeah, start with automatic instrumentation and you automatically apply it. Like, for example, Diego Hurtado once said, but why is zero code instead of automatic instrumentation? Which I don't think it's very helpful as I was describing it. So imagine it as the next step in the process of entirely automating your OTel setup.
Right.
And it is a great idea because you get a lot of value with the instrumentations out of the box. Automatic instrumentation is the cheapest and best way to start you in your OTel journey. And this is the first thing you should reach for, in my opinion.
Yeah, I totally agree. And I've always been saying this because I think that that's the hardest part with a lot of people who are starting to instrument is, oh no, I don't know where to get started. Here you go. And the other thing that you mentioned that was really interesting, I actually remember having a conversation with a friend recently where he was messing around with the auto instrumentation for JavaScript. And he's like, yeah, but I got to do all this work to get it to auto instruments. And I'm like, yeah. So, but to his point, it's like, then it's not really like, this is extra work. So yeah, I'm glad that you're addressing that.
Now, I mean, let's be perfectly honest. I mean, the term auto-instrumentation is unfortunately mutuated from questionable enterprise marketing because it's not automated enough. This is where the injector and the system packages come in to fill the gap. The idea is that you do something, which in my opinion should be just point a finger and say, yeah, monitor that. And data is automatically collected. The point is the amount of work to use today, just the OTel instrumentations without the additional things to inject, it's significant. People get lost in there. Yeah. And that's why we created Injector, we created the packaging, because we really want to make the journey to get started really easy. And ideally, we get to a point in the project where what you automatically inject and the telemetry that is automatically collected is good. It is consistent. It has very sensible defaults. And your job is mostly a matter of adding, for example, through manual instrumentation or different ways, like there is some things in the declarative SDK that can help to add the business context to your applications, which is the 20% of your work, which is great bangs for bucks after that you have gotten value out of the technology monitoring after fashion that you get with automatic instrumentations. What do I mean by technology monitoring? When you go and look at the instrumentations in OpenTelemetry, it's an amazing coverage, like tons of technologies, but that's technologies that they monitor. Any HTTP client that matters on the planet, but what's the meaning of that HTTP request, on behalf of which of your users that request came in. That is the business context that you need to put in. And what I want is that is the only manual work you need to do with OTel.
It makes sense. Yeah, because I think that's one of the things that can be a little bit off-putting for a lot of people starting with OTel is like the ergonomics. And to be fair, I think SIGs like the packaging SIG and the injector have the reason why they exist is to make OTel a more ergonomic experience, which goes to show that like people in OTel are aware of some of these ergonomic issues and are working to make it better, right?
I mean, there is like a common thread among all the people joining the injector and the packaging SIG. With Antoine, Jack, Bastian, all the others, we want easy things to be really easy with OTel. And this is how you reach the masses.
I love that. Now, here's a question for you, because one of the things that can be tricky when it comes to like auto instrumentation is it turns on this fire hose of stuff, right? So how do you ensure that you're not emitting so much information that it's like not useful information?
That is one of the things I was referring to when I spoke of sane defaults.
Mm-hmm.
In reality, what telemetry is useful is a very subjective thing. The practices that you have to monitor your systems, the way your systems work, the failure modes of your system, they're very specific to your application. So something that you can do is, of course, drop in telemetry, filter processor in your nearby friendly OpenTelemetry collector. In other ways, we are building the system packages to rely on declarative configuration, which has a way for you to configure for which languages you want which instrumentations to run. So you have mechanisms to opt in and opt out, which instrumentations you want. It is still a journey to actually have the declarative configuration working consistently across all the languages we want to support. But I'm pretty hopeful that in 2027 we'll land in a place where throwing away telemetry that you don't care for is pretty easy. Now, of course, the job of going and pruning the telemetry you don't care for still very much depends on the user. But the more we lower the bar to get the telemetry in the first place, the more freedom of mind and cognitive capacity will leave for user to curate that little aspect of telemetry.
I love that.
It sounds like the move is toward like maybe prioritizing disabling instrumentation where it might not be needed versus like generating it and then dropping it at the collector, right?
It's I like that you use the word productizing, because something that I am known to say is that I want OpenTelemetry to be a product, not a project. And
love it.
It's easy to use and easy to steer. It's, I think, one of the ingredients that we could put way more into the project we love.
Yeah, I totally agree with that. Now, here's another question for you. When you run on your Linux system, apt install OpenTelemetry or DNF install OpenTelemetry, what is happening?
Ooh, a small series of miracles happens. So,
I love it.
just to manage expectations correctly, right? So first of all, your package manager goes and figures out what you mean by that. It goes and looks up what is this OpenTelemetry package. And that is known as a meta package. It's effectively a collection of other packages to install. Specifically, it says, look, if you want to install OpenTelemetry, you need to install the OpenTelemetry Java instrumentation, the OpenTelemetry injector, the Python instrumentation, the Node.js, blah, blah, blah. Those files, so the content of those packages are of two things. There are the auto-instrumentation packages that deliver, for example, the OpenTelemetry Java agent and a few configurations for it so that the injector knows where it is and what it does. In JS, it's the same. It's a dump of node modules. In Python, there's a bunch of wheels and packages. So it installs the files of the SDKs. It installs configurations for the injector to know which SDKs and auto-instrumentations are available on the system. And then the OpenTelemetry injector package goes and installs the injector itself, which is a system object, .so, which uses LD preload, which is super geeky, and I'm going to talk about it soon, so brace yourselves.
All right.
And it goes and adds the injector to the registered list of LD preload binaries. So every Linux distribution has a file in htc/ld.preload, which is effectively a list of file locations where you put LD preload objects. The LD preload object is a way to steer the linking of an application at runtime to do other things. When you go and, for example, run the ls command or the cat command on Linux, you are telling the system to start that binary. Yeah, it's on the path, it resolves the path, it does uslib sh. Yeah? That binary has dependencies. It has dependencies, of course, on the Linux kernel for the APIs, but it also has dependencies on dynamic libraries. The whole concept of a Linux distribution is to have a system with reused libraries, and the classic two are OpenSSL and the libc, to have all your binaries reuse effectively shared infrastructure. If you remember what happened with Heartbleed, right? And now I'm carbon dating myself. If you had to go and patch every single binary to use a version of SSL that was not affected, it would take you roughly until the heat death of the universe to do that. In most systems, you updated the OpenSSL package and you were safe. Why? Because when you start the application, this kind of shared functionality is linked, added to your program at startup time. And that is what the linker does. Effectively, what the injector does, it hijacks through the linker the way that your JVM, your Node.js runtime, your C Python, your C Ruby, the .NET runtime looks up the process environment. So environment variables, right? Why do we do that? Because every single OpenTelemetry instrumentation that you can automatically inject, in order to work with your applications, needs, one, to be on the file system where your JVM can reach it, and two, set an environment variable that will activate it. Now, Adriana, Reese, what are your favorite programming languages? So that you can make it a bit more concrete.
Oh, mine, I will have to say is Python.
Python. Reese, what's yours?
You know, I think Python.
All right. Python is a very interesting one. So the way Python runs, you have Python installed on virtually every Linux system on the planet. And sometimes you have some very ancient versions. So for example, you will still find around versions of Debian, versions of Red Hat Enterprise Linux that still have the system Python is 2.7, which is effectively something that should have extinguished with the dinosaurs, but still around in cooking. OpenTelemetry instrumentation, that OpenTelemetry Python SDK supports 3.10 plus in the latest versions, right? And if you go and try to run 3.10 code on a Python 2.7, you get some very interesting crashes, right? So what does there the injector, how does it work? The injector goes and modifies the Python path environment variable, which is effectively similar as the path environment variable for the shell, is a set of locations where interesting stuff lives. For Python, the interesting stuff are directories where Python packages are installed. They're known as sites in Python. So the injector has a companion called the system customizer.py, which is effectively a script that Python goes and says, okay, Python path says in the beginning /opt/OpenTelemetry/Python. Cool, I'll go and see what's there. And it opens the folder and it finds a site customize. It goes and runs that site customize. The site customize says, yo, if you are 3.10, load the Python SDK, otherwise ignore this site. that file is added by the injector. The injector modifies the Python path, and that way, every single Python application that starts will go find the Python SDK, check if it can start safely, which is a matter of Python versions, also potentially dependencies, that very long talk. And then, if it is compatible, it will load the Python SDK and all the instrumentations before any of your code runs. And this is how you get no-touch instrumentation.
That is so cool.
Like you said, it's miraculous.
I was going to say, though, like, because, I mean, you do the no-touch instrumentation for, I'm assuming, various different languages. How do you ensure, like, each language has its own nuance? I mean, so, and typically, like, I know for auto instrumentation for various, like, for languages that support auto instrumentation in OpenTelemetry, you've had like different SIGs for all of these, right? So, but here you have like a single SIG that encapsulates all of this stuff. Like that's a lot to coordinate, no?
There is a division of labor. So the packaging SIG, the same way that, for example, the OpenTelemetry operator did not reinvent the Java agent, we work downstream of the language SIGs. They come up with the SDKs. Well, at the moment we're not agreeing much. At the moment we just took what works and packaged it, and we are in the process of liaising with the language SIGs to agree on effectively what is the unspoken contract between the injector and the language. For example, in Java, you should be able to add it with -Java agent, and then it's supposed to work, right? Mm-hmm. Python, we had to go and do the site customized bit because the Python SDK did not have enough safeguards on its own. So there is effectively this process, like we make it work in the packaging SIG, and then we push some of the aspects upstream so that we are directly responsible for that to keep working. Now, as much as I love OpenTelemetry open languages, I cannot say I'm an expert in writing instrumentations for each and every one of them. I know how front end works because otherwise I would not be able to do the injection. But the SDKs and the instrumentations, they come from the language SIGs. And the packaging SIG and the OpenTelemetry operator, we make it easy to consume.
Got it.
Visual labor.
Wow.
It's fun.
Yeah. It sounds like it's a lot of collaboration for sure.
Yeah, but that's, I mean, to make something as complex like injection work butter smooth, takes a lot of people and a lot of sweat and passion, right? It's not what a single person would be able to achieve.
100%.
And of course, I mean, I am also not alone in this, right? There is an entire SIG of people. I'm just getting all the credit, but the both packaging and injector SIGs have amazing people contributing a lot to all of these things.
How many people in your SIG, or in this particular SIG?
So it's a difficult question because so if you talk about maintainers, it's around 5 for each of these. Then of course there is always like some maintainers a bit less present. There are actually people that come in and do the work without being maintainers. So I would say 5, 6, 7 for the injector, 4 or 5 for the packaging SIG. And I expect the packaging SIG to start involving more people because one of the things that we want to do is also to relieve the operator SIG from having to build and maintain the container images for the injection. Images and system packages, they're like 90% the same DNA.
Yeah.
So one of the things that it's already, we have the discussion going for the automatic injection for PHP, where the PHP SIG wanted to create a separate project for the image, and we went and said, hey, let's do it together in the packaging SIG, so that, I mean, we called it packaging SIG, not system packages SIG, because the idea is over time to actually make as many technologies easy to use, easy to monitor with OpenTelemetry, which is mostly a packaging problem. So how do you take technology that exists and make it easy to consume?
How will eBPF-based instrumentation, so for like Go, Rust, or C++, integrate into the Packaging SIG's host distribution model down the road?
It is beautifully complementary. So when you look at the languages that we support in the system packages is Java, .NET, Python, and TypeScript, with Ruby joining the fray as soon as declarative configuration becomes available in the SDK. And remind me to talk about why declarative configuration, because it's very important for the end user experience. The OBI, so the OpenTelemetry eBPF instrumentation, works really, really well with Go, Rust, C++. And it's in order for you to be able to install OBI, you need effectively to have access to the Linux kernel. And OBI works also with somewhat elevated permissions because you need to go and effectively add logic to the Linux kernel. And when you install packages on system, you're also installing them as root, effectively, right? The software doesn't run as root, but you need root permission to add software. So something that we want to do, unfortunately, I don't have a timeline for that because the OBI SIG is very busy making version 1.0, is to actually add another package to the system packages, the OpenTelemetry eBPF instrumentation, so that when you do apt install OpenTelemetry, it will also install for you OBI. So we have full instrumentation. Now, something that I should point out is so far we have spoken about apt install OpenTelemetry, dnf install OpenTelemetry. That's the whole shebang. You go and say, monitor me everything you can. Yeah. OBI is something that we want to add. The OpenTelemetry collector, I believe that the collector releases should become part of the family that you install with apt install OpenTelemetry.
Nice.
The OpenTelemetry packages are not yet part of the family. We need to make a few tweaks, find out a place where to publish the packages together, ideally. It's also possible to use the component parts on their own. So you can go there and make apt install OpenTelemetry Java instrumentation. And that puts the OpenTelemetry Java agent for you. The declarative configuration, like a template, is installed for you. And then you are responsible for activating it by adding the Java _tool_ options environment variable with the right value. So you can actually you do not have to install everything all the time. You could also go as simple as install with injector and Java, and then all your Java applications are monitored and only those. So it's modular by design.
That is so cool. I didn't realize how much SIG interoperability this involved, but I mean, it makes sense after after everything that you've described. It is honestly like, this is so cool. I did not realize how cool this project was. So I'm like, damn, mind blown.
There is a question in the chat asking, does it work with CAdvisor?
Oh yeah, let me pop that over here.
Because the CAdvisor is actually something that you would monitor. So it's effectively a C binary. OBI can probably do something there, but in reality, what you want to do with CAdvisor is actually to go and get metrics out of it. That you can do either scraping them with the Prometheus receiver, or use the K8s cluster receiver in OpenTelemetry collector contrib. And that is a couple of configurations. There are settings in the OpenTelemetry operator, especially the Helm chart, to streamline this setup for you, but I don't remember them from the top of my head. I'm sorry.
No, thanks for grabbing that.
Yeah. Other thing that's I think that might be on various people's minds. What's on your roadmap? I think you've teased a few items.
Yes. So Ruby support. Yes. One of the things that OBI and the collector being part of the family, so that you have a very cohesive experience. The biggest thing that is missing right now to have production enterprise-ready deployment for the packages is actually to find a good way of hosting them. At the moment, we're putting the packages on effectively a GitHub Pages repository, which is not very scalable, and it's a bit hacky. And we're working, especially Denise from the Packaging SIG, has been doing a very cool POC with Copper, which is the way to create packages for Fedora. People from Canonical, Sina, has been coming up with a proof of concept to build and host the packages on Launchpad. I think we are at a point where we think we know how the packages should be built, signed, and hosted. And this is going to be very much the focus in the next quarter. So today, when you want to use the packages, you need to go and tell APT, like, chill down. I know you need to ignore the SSL certificate. It looks a bit dodgy, but it's going to work. And instead, what we want to do is it's something very professional. You just add the repo, tell it to go, and nobody complains because it just works. So it's really the hosting of the package, which is a surprisingly difficult thing. I would not expect it would be so difficult.
I'm not terribly surprised.
We expected to be able to just find a service and put in there the instructions that it works. And instead, it turns out that if you want to have control, for example, of the signature, so that, for example, you want to move the hosting and people don't need to go and nuke their configurations and start over, it's actually very, very difficult. So that was the biggest surprise we had, because for the rest, it worked really smooth.
Damn. Now, I got to ask, these are Linux packages. You planning any like homebrew packages, brew, install, OpenTelemetry?
I personally want to do NixOS because I fell into that rabbit hole and I don't plan ever to crawl back. For macOS, so brew, you can use it on Linux, but it's an audience of one.
Yep. yeah.
For macOS, we would need to write a completely different injector. Because we built or not completely different, but like all the interesting bits, they need to be rewritten because I was talking about LD preload. That's a mechanic of libc on Linux. If you want to do it on macOS, there is a similar mechanism, but effectively you need to rebuild the injector effectively from almost scratch. Yeah? So we do not have a concrete plan to support open operating systems other than Linux, which effectively today will be macOS and Windows.
All right, good to know.
And for example, commercial vendors have done such a thing.
Yeah.
I'm not sure what would be the return on investment to actually take the SIG down that direction. Most developers, they're very comfortable launching a container on Linux and doing things there.
That's the thing, right? I mean, I do my work on a Mac, but all of my dev work is in a dev container anyway, so.
But if somebody in the audience wants to go and take a crack at doing Mac, I will happily work with you on that.
There you go. Challenge issued.
So, Michele, how can community members test these early system packages and start contributing to the Packaging SIG?
It's very simple. You go on the Packaging SIG page, you follow the couple of lines that you need to add to your Linux distro, so the configuration of where the repository is, and ignore the SSL certificate and GPG image. And then you do apt install OpenTelemetry or DNF install OpenTelemetry, and you start your favorite Java, Python, .NET, Node.js application, and see the data flowing. It's really simple.
Awesome. Amazing. That's so exciting. Ooh.
Yeah, by
Thank
default,
you for educating us.
I'm not doing it. By default, the packages are configured through the declarative configuration to expect an OTLP endpoint on localhost. So ideally, you would have an OpenTelemetry collector there, so you can go and install contrib or core from the OpenTelemetry releases, and then have that forward your data off of the virtual machine to whatever backend you want to use. You want to change where the data goes, it's a couple of lines in the configuration file that is shared across all the languages, and then you configure the endpoint and maybe the authentication token, and off you go to the races. So it's really simple. And this is one of the reasons why we are building system packages around declarative configuration. Because for the same reason that we wanted to automate the management of the process environment through the injector, the same we think you should not go and set environment variables on all your processes to set the OTP exporter ECP endpoint. Okay? You should use declarative config for that. So it's a couple of lines of APT configuration, a couple of lines of YAML, and off you go.
Well, that's awesome. You heard it here, folks.
There you go. And I'm just going to flash up the QR code for the Packaging SIG Slack channel for anyone who wants to join.
Or if you'd like to learn more, just hop on over to the Slack channel.
Yes.
Very
and how often does the Packaging SIG meet?
Every week. We effectively share a time slot with Injector because we're mostly the same people. So
nice.
It's half an hour at the Packaging SIG, half an hour at the Injector, back to back.
Oh, cool. That's awesome. Yay. Love the collab.
Awesome. Well, that wraps it up for our final summer episode of What's New in OTel. Thank you so much for being on the show with us, Michele.
My pleasure.
Yeah, this was awesome. I feel so educated. TIL.
An unbearable explainer, right? I over-explain.
No, this is great. This is awesome. Such good information. And I hope this inspires folks who are viewing to check out the Packaging SIG. And if you didn't catch us live, you can always catch us on demand, either on LinkedIn, on the OTel LinkedIn, or on the OTel YouTube channel. We are at OTel-official on YouTube.
And otherwise, we will see you live again every last Wednesday of the month.
Yes, and don't forget, KubeCon CFPs are now open. KubeCon North America, KubeCon EU CFPs are now open. That's March 2027 in Barcelona. And then KubeCon NA coming up November 9th through 12th. Very exciting in Salt Lake City.
Antoine Toulon and I have a talk at Observability Day about system packages.
Oh,
so
nice.
Come and talk about it.
Oh, perfect.
Oh, amazing.
I'll be there. I will come check it out.
That's great. Well, thank you so much, Michele. This has been lots of fun.
Thank you.
Thank you so much. Bye, everybody.
Bye, everyone.